So let's try to solve merge sorted array problem. So we are given two integer arrays nums1 and nums2 sorted in non-decreasing order, which is increasing order, and two integers m and n representing the sizes of nums1 and nums2 respectively, and we need to merge nums1 and nums2 into a single sorted array in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside of the array nums1. To accommodate this, nums1 has the length of m plus n, where the first 10 elements denote the elements that should be merged, and the last 10 elements denotes are set to 0, should not be ignored. So basically, going to give an array nums1 of length m, but they will also have some extra space where we can put the nums2, and so the arrays we are merging are 1, 2, 3 and 2, 5, 6. The result of the merge is so once you merge 1, 2, 3, 0, 0, 0 and 2, 5, 6, you will get 1, 2, 2, 3, 5, 6. So this is the problem, and let's try to take an example. Let's take this example 1, 2, 3, 0, 0, 0, 2, or let's create our own example here. So 1, 2, okay, 1, 3, 5, 6, 9, and so this is so let's say this is nums1, and nums2 has 2, 4, 7, 8. So there should be 4 zeros here, and so let's try to merge this one. So now let's try to merge. So if you start merging from the beginning, it won't be that easy, because let's say you start merging from the beginning. Let's say you replace 1, okay, so 1 need not be replaced, and then 3 you need to replace it by 2. Now you have lost the 3, so now where is 3? So it is better that we solve it from the end. So let's come from the end. So, and remember that we should not be creating another array. We should be merging both nums1 and nums2 inside of nums1. So the function need not return anything, as it says here. You need to return exactly nothing, and nums1 should be sorted in place. So sorted in place, nums1 should be sorted in place now. So let's try to manually sort this nums1 first. Now, so which one of 8 or 9 is bigger? Of course 9, so let's put 9. Let's first initialize pointers first. So let's put I to point out the numbers in the nums1, and j to point out the numbers in the nums2. And let's have a k to point where the elements are. So now we have put 9, so 9 has been put here, and k will go to here, and which one of 6 or 8 is bigger? 8 is bigger, so let's put 8 here. Remember that this is the new nums1. 8 here, and j will move one number backwards, and which one of 6 or 7 is bigger. 7 is bigger, and j will move backwards. So once k was put, so once 8 was put here, k would have moved there, and this would be 7, and which one of 4 or 6 is bigger? So obviously 6. So okay, so let me just handle the k below. That would be better. So k was here and they are here. So after all the modifications, k is now here. So which one of 6 or 4 is bigger? That is 6, and 6 was done with, and I will come here. Which one of 4 or 5 is bigger? That is 5, and so k will move to here. Now which one of 3 or 4 is bigger? That is 4. So j will move here. Which one of 2 or 3 is bigger? 3. 3 cancel. And which one of 1 or 2 is bigger? That is 2. And at the end, you need not make any changes because 1 was already present, because remember that this is nums1 and we were already putting it into nums1. So nums1 is now sorted in order. So now let's write the code for this problem. So let's initialize the variables. So let's just say, now this is in Python. Let me just write that down. So Python code. So merge arrays. Now we are given nums1, and its size will be m, and nums2 whose size is n. So this is the function. Let's first take the index k, which would be m plus n minus 1. Remember that k is the index of from where we are filling the numbers, and let's initialize I and j as well. 2. So I would be m minus 1, j would be n minus 1. Now for the loop, now you might be thinking, while the loop better be initialized I is greater than 0, and okay, so that is C++, and so and j is greater than 0. But no, it would be better if we do just j is greater than 0. Now what's the reason? I will tell you later. Let's just say j is greater than 0. It's actually better if it's j is greater than or equal to 0. So now if I is greater than or equal to 0, just to be safe, and nums1 of I is greater than or equal to nums2 of j, which means it's the case where the nums1 number is greater than the nums2 number. Then we would say that nums1 of index k, then we are only going to put the number from nums1's index. So now we'll decrease the index of I, as we would just go and jump to here, and else, there's only one case else. So if nums1 was not greater than or equal to nums2, then it means that nums2 is the one which is greater, and we decrease j by 1, and in both the cases we also need to decrease the index of k, and then we just return it because we were supposed to solve nums1 by index in place, and we did just that, and nums1 has been sorted in place, and this solution will be accepted in Leetcode. So now why were we checking the index of only this one? Well, because the index of I is being checked here anyways. So index of I, you're already checking it here. Let's say the array of nums1 was over. Let's say everything was sorted from here, but there were some elements in nums2 which needed to be sorted. So then only this part will be executed in this loop. So that's why we are checking only j is greater than or equal to 0. There's another type of this problem where they check both I and j here, and then they will try to put the index, and then they will have another loop here trying to put any leftovers from nums2. But this is a simpler version of the code where we just put the where we just check the index of the nums2 and then put the okay, let me just not do that. Sorry, that was unintended. Okay, so that's why we have just checking the j index here, because i's index is being checked here anyway. So let's say if I is 0, then it means that only j is left. If j is 0 but I needs to be still filled, let's say everything from nums2 was filled but there are still some left here, then this would be executed. So this is a perfectly valid program, and this is how we solve it. Okay, let's meet you in the next video, or maybe not.